Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on the confidence interval on the mean. For this video on this PowerPoint, we are working with X being normally distributed with a population standard deviation or sigma as a known value. An approximation for large sample size n greater than 30. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos, and this is part 1 of the series. I feel like I've been nagging students about notation, so I'll just have to nag some more. To create confidence intervals, the first part of our notation will be to understand and to know what Z sub alpha means. Notice the way I read that, Z sub alpha. Sub means that it's a subscript. That means it is lower and smaller, lower below the line, and a smaller text than the other normal lines. It does not mean Z times alpha. Let me say that again. It does not mean that Z is multiplied by alpha. It does mean that it is the Z associated with a particular alpha, where alpha is another variable that we will now use. See if you can recognize the pattern on the next slide and then label the question marks appropriately. And again, remember, alpha is another variable that we will use, so we will now place numbers in place of that alpha. So we have a normal curve, and we've shaded an area of 0.10 or 0.10, and we've shaded that to the right, and the Z underneath that is labeled as Z sub 10, Z sub 0.10, excuse me, or Z sub 0.10. Our next curve, we will shade 0.32, and that Z associated with that mark is the Z 0.32, Z sub 0.32. The third one we have shades 0.70 to the right, and that Z is Z sub 0.70. Notice that now that you've seen the pattern, notice the pattern there. How would you label the following Z sub alpha values, and how would they be labeled? Think a minute of the picture that you have here. A normal curve with 0.15 shaded to the right. How should that be? What should the Z value be? That is Z sub 0.15. We have a curve with 0.45 shaded to the right, and that is Z sub 0.45. Our last one is a curve with 0.35 shaded to the left. Notice that this is not Z sub 0.35, it is Z sub 0.65, because it should be the area that is to the right, not the area that is to the left. Even though we've labeled it 0.35, it is the area to the left that's associated, not the area to the left, but the area to the right that we associate with the Z. What is Z sub alpha? Z sub alpha is the z value with the area to the right. So what should z sub alpha divided by 2 be? Well, it's where alpha divided by 2 is the area to the right. Z alpha sub 2 is the area with alpha divided by 2 to the right. And again, it's not something that's multiplied. It's one value. It's the z-score associated with that area in the tail to the right. How would you find z sub 0.10 using a z-table? Now that we have a working concept of the notation of z sub alpha, we need to be able to find that particular z value using a table or a calculator. First, we'll look on how to use the table. This means that there is an alpha or an alpha divided by 2. In this case, that would be 0.10. First, we would draw the curve. Then, since that is an area to the right, we would label and put 0.10 or 0.10 to the right in that curve. Remember that the table that we use and the calculator that we use, the TI-83 and TI-84, use the area to the left. So the next step would be to mark the area to the left, and since it adds up to 1 minus 0.10 is 0.90 or 90%. If 10% is in one tail, 90% is on the other side. So we're looking for the z-score that separates those two areas. Then, if we're using the table, we will look on the interior of the table for the score as close as possible to 0.90. And that would be 0.8897. That's as close as possible as we can get in the z-table. And then looking out from there to find the z-score or the z-value that matches that would give us z sub 0.10 equaling to 1.28. I myself have trouble looking in the table for the interior numbers and then working my way back out because of an astigmatism makes the numbers jump and make it hard to stay on the same line. So I like to use the calculator in this point. So for me, what I like to do, and it's still doing the same thing because we're just looking up the z-score. So I like to use the calculator. So I go and press second and then the distribution, which is above the vars key, and we have our distribution menu. Then you're going to choose inverse norm. In this menu we have, and we can choose, this is the menu we use instead of looking up the values inside of the table. Then in our case we're going to press the area to our left, which in our case is 0.90, and press enter, and that will give you and round that answer to 1.28. If you have a TI-83, that should be then your answer. If you with the newer calculators, once you press inverse norm, you will get what I call a sub-menu, which asks you to press 0.90 for the area to the left, 0 for the mean, and 1 for your standard deviation, because that's the standard normal table. Then press enter, and you still get the same answer as we had before, and round that to 1.28. I always then like to go back to my table and look up 1.28 and see that yes, that is very close to 1.90. That way I'm checking and using my table. Either way, the z sub 10 is 1.28. And that's 0.10, excuse me. Okay, let's try one more. If you're feeling very brave, pause and try it on your own before continuing. But how would you find z sub 0.70 using the z-table? Draw your curve. That would be 0.07 to the right. Z sub 0.70. That leaves us 0.30 to the left. So we're looking for 0.30 in our table. The closest value would be 0.3015, which would give us negative 0.52. If we're using our calculator, you would go second, distribution, inverse norm, negative 0.52, and then enter. On the newer calculators, second, distribution, inverse norm, not negative 0.52, excuse me. I am so sorry. That should have been, in both cases, to use the calculator. Second, distribution, inverse norm, the area to the left, which is 0.30, enter, round that decimal to the 2 decimal places and get negative 0.52. On a newer calculator, second, distribution, inverse norm, the area to the left, which is 0.30, the mean of 0, the standard deviation of 1, enter or paste and then enter, and that will give you a z-score and round that to 2 decimal places, which is negative 0.52 as well. And this is a good place to pause. I hope that last little hiccup didn't confuse you too much. But I'm going to end the video here, and I will pick up in the next video. Thank you for watching.